Well, welcome back, ladies and gentlemen. We are going to continue on this unit by talking a little bit more detail about the periodic table, how it's organized, what are some of the groups called, and what are some of the properties that we are able to determine based on certain trends and things like that on the periodic table. So again, just a couple of quick reminders about our learning targets for today. Hopefully you'll be able to understand how the periodic table is organized and then relate some very important properties to that periodic table. It's organized in a very unique way and a way that makes trends very easy to see as we look on that periodic table. Just a couple of key vocab terms for you for today. We'll talk a little bit about periodic law. Hopefully you know the periodic table by now because I've only mentioned it about 9,000 times in this class. Alkali metals, alkaline earth metals, transition metals, lanthanides, actinides, halogens, and noble gases. So let's get started. So just to kind of get us an idea, on the right hand side here, what you have is the very first periodic table of elements. Now, a Russian chemist by the name of Dmitry Mendeleev organized a large amount of information about the 60 elements that have been discovered so far. And he noticed that there were several repeating trends that you actually see on the periodic table. And that really helped out with the process of organization. So as you see here, if you look at some of the columns, they're very representative of, rather than columns on our current day periodic table, they're very representative of the periods on the periodic table. So these particular trends are known as periodic law. So if you look there, there's a lot of elements, and those elements are listed in, well, essentially what the order is of elements on the periodic table today. Now keep in mind that only 60 of those elements had been discovered. If we look at the periodic table now, it's almost double that with 118. So while this is very crude and very rough, it actually does have a pretty good representation of what the periodic table is today. If we take a look at it now, there's 118 elements that are on the periodic table today, and they're arranged primarily by their electron configurations. The rows going across are known as periods, and the columns going up and down are groups. And what you'll find is that the groups on the table share some very, very similar chemical properties. The first one we're going to look at today is what's known as the alkali metals. These are the ones in group number 1 that is on the far left-hand side of the periodic table. Now, these are all considered metals, but they're actually very soft metals. They're very, you could take a knife and just kind of cut right through it, as where if you tried to do that with some of the harder metals like copper and silver and whatnot, you probably wouldn't be able to do that. They're very reactive with other elements. The reason for that is that they have one valence electron. Because they have one valence electron, they want to get rid of it so that way they have a stable number of 8. So they readily bond with lots of different materials, and in many instances when they do bond, it's a very violent chemical reaction. All of them only have one valence electron, so everything in that first group just has one valence electron, and one of the big reasons for that is that their electron configurations end in S1. So if we take a look now at the D block transition elements, which are elements between the S block on the left-hand side and the P block on the right-hand side. These are metals that you're probably more familiar with, things like nickel, copper, zinc, silver, gold, platinum, iron, etc. These are very good conductors of electricity. And their electron configurations can be a bit odd at times. So if we look at copper down below, if you were to just follow the order, copper would have 2 electrons in the 4s orbital and 9 in the 3d orbital. But what we found is that it is actually more stable if it has a full d orbital. So it actually takes one from the s orbital, making the electron configuration 3d10 for s1. Now, you don't need to worry or stress about this, but I do want you to understand that's the rationale for some of the number of valence electrons that are found in some of these transition elements. If you look down below the periodic table, you'll find the lanthanides and actinides, and these are our F block elements. They're full of rare earth metals. These are things that you do not find very often. And as we go beyond 92, we find a bunch of man-made elements, things like plutonium, americium, curium, berkelium, etc. And some of these rare earth elements have some very interesting properties. Neodymium, for example, is a very, very magnetic substance. I used to own a neodymium magnet, and you have to be really careful with it because you get it near a metal surface, it'll jump out of your hand and go right to that metal surface. It's pretty interesting. Keep in mind that these are kind of an extension of the periodic table that's just shown below the rest of the periodic table. So they're not kind of like in addition to, they are a part of that periodic table. A couple of other things we're going to take a look at, some of the P block elements. Now these properties can vary greatly as we have metals on the bottom left, things like tellurium, lead, bismuth, non-metals in the top right, fluorine, chlorine. And we talked a lot about metalloids, things that exhibit both properties of metals and non-metals. So the P block elements can vary greatly in the chemical properties that exist. A couple of other groups we need to discuss. Group 17 on the far right hand side, those are known as halogens. Things like fluorine, chlorine, bromine, iodine, astatine. These are the most reactive nonmetals. So very much like how the alkali metals want to give away an electron in order to become stable, these particular elements want to accept an electron in order to become stable. So they're very reactive and tend to react with lots of different chemicals. They're very reactive with alkali metals, alkali earth metals as well. And the last group is group 18, and these are known as your noble gases. And noble gases typically are very unreactive. The reason for that being is that they have 8 valence electrons in their outermost shell. They do not want to gain or lose any, so most of the time they don't chemically bond with anything else. You'll also find that most of these elements exist as gases. As you see here, we talked about neon lights, and if you run an electrical current through all of these, we talked a little bit about emission spectrum and how light is emitted when that electron goes from an excited state back to the ground state. We can take a look at all of the different colors that can be produced by the different elements that are found on the periodic table. Something that we need to make sure that we address, and I will go ahead and address it now, although we'll probably take a look at it again when we start talking about chemical reactions, are what are known as diatomic elements. And these are elements that cannot exist on their own. So for example, you will never find a hydrogen atom by itself or a nitrogen atom by itself in nature. They're typically either bonded to other things, or if they're not, they bond to themselves. So you'll see this quite a bit. If I ever write hydrogen, I'll never write H, I'll always write H2. That's because the chemical element bonds to itself when it's in its elemental state. The easy way to remember this is by the abbreviation Brinkelhoff. I always remember that as David Hasselhoff's stranger cousin, weird cousin, but Brinkelhoff, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine cannot exist by themselves. They have to be paired up in what's known as a diatom. Di means two, atom means, well, atom. So hopefully you understand a little bit more about the periodic table. It's a very unique and organized structure, and it's arranged in a very specific pattern. The properties of the elements are common among groups on the periodic table, so the properties of the alkali earth metals will be very similar. Alkali earth metals, again, very similar. Halogens, noble gases, etc. Different groups contain elements that do have some different properties. We looked at the P group, you can see that there's a lot of different properties that are there. But one thing to keep in mind is that the periodic table is organized in a very easy to use way in order to be able to find trends amongst the elements that exist on that periodic table. Hopefully you get the learning targets today, and we will see you next time. Bye-bye, guys.